Okay, so here's problems 11, 12, and 13, and I just put down here on the bottom the uh, SOHCAHTOA sine, cosine, tangent relationships for the opposite sides. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for this first problem, number 11, they're looking for the sine, cosine, and tangent of m. So what is m? There it is. You can see that for sine, we can say, and you should write it like this. You should say um, sine of m. You should always pronounce it sine. Don't say sin. Don't say cos. Say cosine. Don't say tan. Say tangent. That's just, it'll drive people bonkers if you do that. Okay, the sine of m is equal to its opposite side, which the opposite side of m is 7. Over the hypotenuse, and the hypotenuse is 25. Okay, the hypotenuse is going to be the longest one. Um, so remember the words opposite and adjacent and what they mean. Opposite means across from. Okay, so in this case, what's across from m? That side, that's 7. Yeah, and so then the cosine will be the adjacent over the hypotenuse. And what is the adjacent side? It's the one right next to it. And you might say, there's two right next to it, Mr. Massey. These two. Yeah, that's true. But one of them we always call the hypotenuse. So we're not going to call this 25 the adjacent side. We'll always call the longest side the hypotenuse. So we've got a 24 then as the adjacent side. So 24 over 25. And always for sine and cosine, you're going to get a ratio that's equal to less than 1. The numerator will be smaller. And that's because the hypotenuse is always on the bottom and the hypotenuse is always the longest. So, okay. And then we've got for tangent of m, the tangent is the opposite over the adjacent. So what we have for the opposite side, 7. What do we have for the adjacent side? 24. Yeah? That's what we've got for number 11. We're going to repeat that for the number 12 and 13 as well. Okay. Again, we're doing angle M. And by the way, if we need to, we will simplify the ratio that we get. Okay. So here, let's say sine of M in this case is opposite. What's opposite to angle M on number 12? Opposite is 4 root 2 over hypotenuse, which is 9. Okay? And then the cosine of M is the adjacent side. What's adjacent to the angle M that's not the hypotenuse? That's 7. Over the hypotenuse, 9. And then the tangent of M. Tangent of M is opposite over adjacent. So 4 root 2 over that adjacent side of 7. Okay? And finally, for number 13, again, we're doing angle M here. Okay? So we then say sine of M sine of M is opposite. Opposite of this is 2 root 3 over hypotenuse, which is 4. And of course, you should be able to see at this point that the 2 and the 4 here, circle them in this pink, they can be simplified dividing them both by 2. Okay? And when we do that, the 2 simplifies on top to a 1, so it's just 1 root 3, or they call it root 3. They don't put the 1 in front of it. They don't need it. And on the bottom is 2. So let's see if we can erase that. Yep. Um, okay, so that's what we get for sine of m. Now, cosine of m is adjacent over hypotenuse, and the adjacent side for m is the 2 that we see there over the hypotenuse, which is 4. And of course, that can be simplified. 2 over 4 can be simplified to 1 over 2. And finally, we're going to get the tangent of m is opposite over adjacent. What's opposite m? 2 root 3. What is adjacent to m? Adjacent to m is side 2. And that can be simplified as well. The 2's canceling out, and what you get is just root 3, because these 2 and 2 here, they cancel out. Okay, so that being the case, oops, sorry, I didn't mean for that to erase. Sorry for the delay here. So we've got 2 root 3 over 3. Oh, sorry, 2 root 3 over 2. And those cancel out. And you don't need to always have a ratio. You can have what we have here as root 3. That's what the ratio is equal to. Like if you divided the numbers, that's what it would be equal to. So that's perfectly fine written the way that it is. Okay. So for this last one, number 13, because the numbers are they're all multiples of 2, they're all even numbers in the front, then you can simplify them all down, and you should always simplify them.